I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
Imagine talking to a machine that not only understands what you're saying, but can respond with context, reasoning, and even creativity. That's the power of large language models, or LLMs. In just a few years, they've gone from niche research tools to some of the most transformative technologies in modern computing, reshaping industries, accelerating science, and redefining how we interact with machines. So, what makes them so powerful? At their core, large language models are built on something called the transformer architecture, a breakthrough introduced in 2017. Traditional models used to process words one at a time, almost like scanning a sentence with a flashlight. Transformers flip that idea. They use a mechanism called self-attention, which lets the model look at all the words in a sentence or even an entire passage at once, and then figure out which ones are most important to each other. Take the sentence, "The cat sat on the mat because it was tired." A transformer can instantly recognize that it refers to the cat, not the mat. This ability to capture long-range relationships gives models like GPT-4, Google's Palm, and Anthropic's Claude their uncanny grasp of nuance, coherence, and meaning. But how do they actually learn? Training an LLM starts with something called pre-training. The model is exposed to enormous datasets, everything from books and articles to code and scientific papers. Its task is deceptively simple: predict the next word in a sentence. Yet by repeating this prediction task billions of times, it gradually learns grammar, style, reasoning patterns, and even facts about the world. Once pre-training is done, the model goes through fine-tuning. Here, smaller, specialized datasets teach it how to perform particular tasks, like translation, summarization, or customer support, with greater precision. Some models also use reinforcement learning from human feedback, where people help guide responses to make them more accurate, safe, and useful. The result is a system that doesn't just generate text. It adapts, reasons, and transfers its knowledge to new problems. That's where transfer learning comes in. A model trained broadly on internet text can quickly adapt to niche areas like legal contracts, medical literature, or software code without needing to be rebuilt from scratch. So where are LLMs making the biggest impact? In healthcare, they're scanning medical journals, helping doctors summarize patient histories, and even analyzing images in new multimodal systems like China's Path Orchestra, which can study tissue samples across multiple organs. In education, they're acting as personalized tutors, breaking down complex topics and generating interactive lessons. In business, they're powering customer service chatbots, productivity tools, and even drafting reports and emails. In creative industries, they're brainstorming with writers, scripting videos, and co-authoring stories. And in software development, tools like GitHub Copilot are writing code, spotting bugs, and accelerating workflows. The field is evolving at lightning speed. OpenAI's GPT-5 now leads the pack, alongside Google's Gemini 2.5 Pro and Meta's LLaMA 4. New challengers like DeepSeek R10258 are pushing hard on mathematical reasoning and logical accuracy, cutting down hallucinations and raising the bar for what LLMs can do. Some models focus on raw power with trillions of parameters, while others prioritize efficiency, safety, or multilingual capabilities. Increasingly, we're seeing multimodal models that don't just process text, but can also interpret images, audio, or video. Of course, challenges remain. These systems are not truly understanding in the human sense. They sometimes produce errors or so-called hallucinations, presenting false information as fact. They inherit biases from the data they're trained on, raising ethical and fairness concerns. Training and running them consumes enormous energy, making sustainability a real issue. And there are risks of misuse, whether for disinformation, deepfakes, or malicious code. But solutions are also emerging. Developers are grounding responses in trusted databases, adopting energy-efficient architectures, and building safeguards into model design. Governments are stepping in with regulation, like the UEAI Act, while companies are experimenting with transparency tools that document how these models are built and what their limits are. The future points towards smaller, specialized models that are faster, cheaper, and easier to deploy, as well as increasingly multimodal systems that combine text, vision, and sound in seamless ways. And while some see LLMs as a stepping stone to artificial and general intelligence, what's clear is that they're already transforming how we live and work. The path forward is not just about making models bigger or smarter, it's about making them responsible, transparent, and aligned with human values. If done right, large language models won't just be powerful tools, they'll be trusted partners, helping us build a more informed, creative, and connected world. Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.